We will now go over section 10.2 in your book. We're going to talk about central angles first. In this chapter, we'll be talking about several different types of angles in reference to circles, and central angle is one of them. The important thing to remember about these angles and circles is where the vertex lies. A central angle has its vertex as the center of the circle, like its name says, and the two sides of the central angle are radii of the circle. When you have central angles that do not overlap, like these, they will all add up to 360. This is why we say that circles have 360 degrees all the way around. All the angles together that make up the entire circle always will add up to 360 degrees. An arc is a piece of the circle that's made by 2 points that are on the circle. RP is an arc. We can also call that PR. And this is also another arc. We'll talk about the different types of arcs in a minute. But I want you to look at the relationship between a central angle and what's called its inscribed arc, or the arc inside the angle. So for central angle RQP, this red arc is the inscribed arc. All arcs have two different kinds of measures, a degree measure and a length measure. We're going to look at that degree measure first. Whenever we talk about the degree measure of an arc, we'll put a little m in front of the name of the arc. So the letter M, lowercase letter m, and the name of the arc, RP or PR, means the degree measure or the arc angle measure. Now, I'd like you to open up Sketchpad and do this investigation. Alright, now we're going to talk about the different types of arcs and how to name them. We're going to do this a little bit differently than your book does, so listen carefully about how I go over naming arcs. First, we have minor arcs. Minor arcs are going to have a degree measure that is between 0 and 180. And that's the one that's equal to the central angle. The minor arc will always be inside the central angle there. Minor arcs are named by their endpoints, so they only have 2 letters in their name. Notice that we have this symbol over the name of the arc that shows us that this is arc. Remember that there are lots of different shapes that have 2 letters in their name: segments, lines, rays, and now arcs. So be very careful that you pay attention to that symbol over those 2 letters so you know exactly what they're referring to in the picture. Here, this sentence tells us that a minor arc, AB, this M in front of it tells us that we're talking about the degree measure of that minor arc, and that is equal to the measure of the central angle ACB, which in this picture is x degrees. A major arc is going to measure between 180 and 360. So we will always name major arcs with 3 points. That's how we're going to be able to tell the difference between arc AB, which is this minor arc here, and arc ADB, which is the major arc. Notice they have the same endpoints, so the only way I can tell the difference is to name one with 2 letters and one with 3 letters. Now your book will sometimes use 3 letters to name a minor arc, but I will always use only 2 letters, and I ask that you do the same. Notice that arc AB, minor arc AB, and major arc ADB add up to 360. So I can always, if I know one, degree measure of an arc, figure out the other by subtracting from 360. That only works if both arcs have the same endpoints. Finally, we have what's called a semicircle. Semicircles are also named with 3 letters. They're endpoints and then a point in between them. Semicircles are special because their endpoints will also be the endpoints of a diameter. Semicircles are 180 degrees always. Therefore, the pictures will not have to tell you that that arc's measure is 180. You should be able to know that by seeing that it is made by a diameter or a segment that goes through the center of the circle. Adjacent arcs are arcs on the circle that have exactly one point in common. For example, arc HJ and arc JK both share point J, so they are adjacent arcs. I can add the measures of these two adjacent arcs to get this total measure of this arc made by those two. So the measure of arc HJ plus the measure of arc JK is equal to the measure of arc HK. We can see the same in this picture here, that these two arcs, XY and YZ, add together to give us the measure of arc XZ. Now let's talk about the other measure of arcs, the length. The length is the actual distance around the circle between the two endpoints. We're going to use a proportion to help us to figure out how to find the length of an arc. Remember, a proportion is 2 equal ratios. So we're going to look at 2 ratios, a ratio of degrees and a ratio of lengths. So first, in our ratio of degrees, we have a part of the circle, which is the degree measure of the arc, or the central angle. And then we have the whole circle in degrees, which we know is 360. For lengths, we have the length of the arc, which is the part of the circle, and then we have the length around the whole circle, which we call the circumference. We can use this proportion to solve for any missing piece. So if I know the central angle measure and I know the circumference or the radius of the circle, I can solve this proportion to figure out the length of the arc. If I know the length of the arc and the radius or the circumference, I can figure out the central angle measure. This proportion also makes sense, so it's easier to remember than the formula that they show on the next page. So you'll want to use this proportion whenever you're trying to figure out the length of the arc, or you know the length of the arc and you want to figure out either the central angle or the circumference.